This is AQA A-Level Chemistry. We are on the alcohols topic from year 12, and this is part 4 in the series of alcohol videos. In this particular video, we're going to focus on oxidation of alcohols, specifically what we do to primary and secondary alcohols. As always, I'm going to recommend that you pause the video as you go through, try out any activities that come up, and see how you've done. So when you're ready, we will start working through. The first piece of information here is a reminder of lots of work in the redox topic, and I think it is important to know that we are starting here to draw in wider, more general information that you will already have covered. So, for example, you will know that oxidation is loss of electrons, reduction is gain of electrons, and that's what oil rig comes from. You'll also have discussed that oxidation is gain of oxygen, reduction the reverse. Oxidation is loss of hydrogen, and reduction gain of hydrogen. All of them you need to be familiar with. And you also need to be very familiar with the terms oxidizing agent and reducing agent. Remember that an oxidizing agent is something that is itself reduced. Reduction is gain of electrons. So in the context of an oxidizing agent, we don't say gain electrons, we will say accepts electrons. And similarly, a reducing agent is itself oxidized. Oxidation is loss of electrons. So as a reducing agent, we talk in terms of donating those electrons. So it's all about the context in which we're looking at the species. Okay, let's take a look at some questions about the oxidation of alcohols. See how you do, and then we can review. So a huge amount of this is within the required practicals, and we're going to go over the summary information that goes alongside that. What is the oxidizing agent that we use when we oxidize an alcohol? Well, I'm going to put this down in a number of different ways. Its full name is acidified potassium dichromate 6. There is a particular word there that you will not want to miss, and I've highlighted the acidified. Potassium dichromate 6 on its own will not get you the mark. We have to talk about the acidic environment that it is in. We can write them out as the dichromate ion, Cr2O72-, or the potassium dichromate, K2Cr2O7. But again, we've not yet got the mark. We have to show that this is acidified. So in this format, you would need to include the H+. Once we've got our head around all of that, we need to know what observation we make if we use acidified potassium dichromate 6 to oxidize an alcohol. And what we see is the change of colour from orange to green. And how do we actually represent it? Well, we're very fortunate that we don't put a huge amount of detail in. We simply use a square bracket, round an O. And that O represents the oxygen from the oxidizing agent. So let's move on. Let's look at primary alcohols, what they're oxidized to, and what might happen under reflux. We also need to know what reflux actually means. So a primary alcohol will always be oxidized to an aldehyde, and we're going to see that in action a little later on. If it's carried out under reflux, we do get a different oxidation product. So the under reflux here is key. And I've drawn a diagram here to represent reflux. We have a Liebig condenser, we have water going in, water coming out, we're heating from below, and we need to think about A, what that leads to, and B, why we do it. Well, if we do take a primary alcohol and we oxidize it and we do this under reflux, it doesn't stop at an aldehyde, it goes to a carboxylic acid. So ethanol goes to ethanal, goes to ethanoic acid. What do we actually mean by the term reflux? Well, what's the purpose of this upright condenser? Ultimately, when we make the aldehyde, aldehydes are incredibly volatile. So they could escape into the atmosphere. They could go from the reacting vessel before they are oxidized further. But if I have an aldehyde that's very volatile that's formed and it rises up into the condensing column, it condenses, it cools, it comes back down to be reacted further. So it won't escape out into the atmosphere. And that means it goes back into the flask to be further oxidized. Let's now take a look then at the equations for what might happen in each of these examples. Have a go and see how you do. Well, the first one, ethanol, not under reflux. So that tells us that it will only go as far as an aldehyde. And here's my ethanol, and here is my ethanal. I am adding my oxidizing agent, which we said earlier in this video is represented as an O in square brackets. So we don't need to worry about acidified dichromate 6 going into the equation. And when we then look through what's left over, once we've done this reaction, we have two H's and an oxygen left. We make water as the secondary product. Let's now take a look at the next example, propan-1-ol under reflux. Well, first of all, we have got propanol, propan-1-ol going all the way to propanoic acid. Now, in this particular case, you've actually got a two-step process because we can add an O that would take it from propan-1-ol to propanal and another O that would take us from propanal to propanoic acid. So the balancing on this is crucial. We are going to need to add two of the O's, and we do get the H2O from the first step, and we're going to see what happens with the formation of a carboxylic acid from an aldehyde a little later on. Oxidation of propan-2-ol. Well, propan-2-ol is a secondary alcohol, and secondary alcohols are oxidized to make ketones. So propan-2-ol goes on to make propanone, and we get the water there as well. And here you can see secondary alcohol going to ketone. Primary alcohol goes to aldehyde, and under reflux can go to carboxylic acid. One more example, the oxidation of ethanol. So we're starting at the aldehyde here. And with the aldehyde, we add our O in square brackets and we go to the carboxylic acid. Ethanol becomes ethanoic acid. There's no secondary product here. And if we, again, just to reinforce the idea, what about if we started at ethanol and went all the way to ethanoic acid? Well, the ethanol to ethanal would be adding one O and making an H2O, and the second O takes the ethanal to ethanoic acid. So this is the equation that you would expect to see. That takes us to the end of this video. Thank you for listening and goodbye.